Hello student, how are you? Today we are going to study power system, a transmission line model theory. And first we are going to study basic concept of transmission line, and then we are going for types of transmission line and the performance and the characteristics and how to improve the power factor, and all the concept we are going to study from the today lecture. Okay. Next. So first one we should understand as a power engineer performance characteristics of transmission line and losses and voltage drop of the transmission line. So these are the important factor every power engineers everyone should understand. So under this one, so what are the in detail study we want to do before we make a design of transmission line model. First one, we have to see the measurement of voltage increase and charging power in lines of different length in no load operation. So transmission line have different length, so it is connected with the load and without load. First step, before we connect the load and different length of transmission line, we should see the how the voltages are increasing and how the power flow there in the transmission line. The second point, we have to understand for the concept of operating capacitance. So each transmission line certain length we connect the capacitor bank. It is for what purpose? It is for power factor improvement. And that also we should understand what is the type of capacitor we want to connect and how much capacity and how much distance in the transmission line we have to connect in each capacitor bank between this. This is also every power engineer should know. Third point, they should know a different performance characteristics of overhead transmission line and cables. So each transmission line have the different characteristics. It's based on the length and based on the capacity of the power transfer flow through the transmission line and the material. Next one, they should understand current and voltage ratio of a transmission line. So IV ratio also the power engineer should know. With what type of load? A mixed of RL load, that is resistive and inductive load, and purely inductive load also. The last one, the power engineer should know how much voltage drop in the transmission line and power losses and efficiency of the transmission line and also voltage regulation. So these are the factors before they design transmission line, and they should know these are the factors, and they should make a pre-calculation before they go for the modeling of the transmission line. So okay, next, what are the types of transmission line in terms of length? Actually, in the standard power engineering standard, they classify three types of transmission line according to the length. The length, they first one they set short transmission line. Next one is a medium transmission line. Next one is a long transmission line. So what is the short transmission line? What the power engineering standard said short means what? The line length is up to 60 kilometer and the line voltage is lower than the 20 kilovolt. So this type of specified value of the length and the voltage 20 kV and the length is 60 kilometer means the type of transmission line is a short transmission line. Okay, so what about the medium transmission line? The line length is between 60 to 160 kilometer. So this is, we say, medium transmission line. And what is the voltage range? Voltage range from 20 kilovolt to 100 kilovolt. So this is the range for medium transmission line. Okay, what about the long transmission line? So long transmission line, the length is 160 kilometer and the line voltage is more than 100 kilovolt. Okay, so from this slide, what we understand, the transmission line classified according to the length and voltage range. They classify short, medium and long. So this is the value of the length of the transmission line and voltage. These are the factor is considered it is belongs to short or medium or long transmission. Okay. The next one we want to study detailedly what is the transmission line parameters and what is the coefficient, okay, of the frequency and factors, wavelength and everything. So for this slide, every transmission line have the three basic electrical parameters. So what are the parameters? Because transmission line means a conductor. The conductor have the electrical resistance, inductance and capacitance. So we study the fundamental in our level 1, level 2 courses. It is R, L and C. So R is resistance, L is inductance and C is a capacitance. So this is the combination is we can see in the our transmission line conductor, if it is single phase or three phase conductors. Okay, as the transmission line is set of conductor being run from one place to another supported by a transmission tower. Okay, everyone you can see in the road, in the highway, and they put very big tower, and the tower maybe 10-15 towers, they make it different distances, they make it, and the lines, the conductor, transmission line conductors are is connected between the tower to tower. Okay, so it is three phase system and they can connect with the four wires, grounded and neutral wires also. So this is everywhere you can see in the highway and they connect from one place to another place. The parameters are for these conductors are distributed uniformly along the line. So the parameter what we say R, L and C, they distributed across the transmission line between the tower 1 to tower 2, for example, uniformly they distribute. Okay, the next one, the electrical power transmit, that is the major purpose for the transmission line, is transmitted over the transmission line with the speed of light is 3 multiplied 10 power 8 meter per second. So this much speed the power transfer through the transmission line. So what is the frequency of the power transfer? It is depends upon the country to country. Some country they are using 50 hertz. Some country they are using 60 hertz. For example, in Saudi Arabia they are using 60 hertz, and in America they are using 60 hertz. Like European country and India they are using 50 hertz. So this is depends upon the country standard, and the wavelength of voltage and the current of the power can be determined by using the standard formula. Therefore, that is lambda equal V by F. Okay, so that we can substitute the value of the speed of the light and or by the frequency. It depends upon the country. If your country is 60 hertz they are using, you can put here 60, and this equation they are using 50. Then they get the result of 6000 meter. This is the wavelength of the voltage and current of the power transfer in the transmission line. So, okay. Next one, the formula for this one is F, the frequency multiplied with wavelength equal to voltage, where F is the power frequency and lambda is the wavelength and U is the U or V, they can say this is the speed of the light that we see in the previous slide, 3 multiplied 10 power 8. And hence, the wavelength of transmitting power is quite long compared to the generally used line length of transmission line. That is our conclusion we can get from this formula. And for this reason, what they are doing in the power engineers, the transmission line, the length less than 160 kilometer, that is what we say, we study already short, medium and long. Long is more than 160. And what they mention here, they said less than 160, they mean short and medium. The parameters are assumed to be lumped and not distributed. So what we say before, the parameters of transmission line uniformly distributed. Now the standard set, if your transmission line length it is less than 160 kilometer, so what do you want to do? When you make a design, you don't want to go for the distributed parameter, you have to make a parameter of the conductor, the lumped one, that is RLC. Such lines are known as electrically short transmission line. So short transmission line, the power engineers, they are using not distributed type, this is the lumped type of parameters. Okay, it's clear. The next one, this electrical short transmission line are again we can categorize as a short transmission line length up to 60 kilometers that we study already, and medium transmission line is 60 to 160, and the capacitance parameters of short transmission is ignored, whereas in the case of medium line capacitance is assumed to be a lumped one. So in short transmission line, so we don't care about the parameters, it's ignored, but the medium is very important, the capacitance should be connected, but in terms of lumped, in middle of the line they connect. The transmission line we have, they connect the transformer capacitor, middle of the line they connected, and half of the capacitance may be considered to be lumped and each ends of the transmission line. So they connect each end of the transmission line, half of the capacitance, and the middle of the transmission lines like this, then they connect middle capacitance. This is for only for medium transmission line, but for short they ignore this type of parameters connection. But medium transmission line they connect lumped type, not distributed type. The next one, lines with the length more than 160 kilometer, maybe is a long transmission line, what they said, the parameter is considered as a distributed type over the line. This is called, we can say, long transmission line. So what we understand at this slide, short transmission line, you don't want to consider the parameters is lumped or distributed, just ignore. But medium transmission line, you have to consider the parameters, the capacitance is connected middle of the transmission line and both the end of the transmission line also. But the end of the transmission line capacitance value is half the capacity of the middle one. The long one, that is 160 kilometer more than, this case you have to consider all the parameters, that is RLC, in distributed format. So this is the design you have to consider before making a transmission model. Next one, in detail we can see short transmission line. In short transmission line, the length less than, we can say, 50 miles. This is depends upon the length, how they say before 60 kilometer, now they said 50 miles. It is depends upon the country to country vary, and also it depends upon the power industry standard. Some of the, for example, IEEE standard set some distance and IEC standard say some distance, and some other SIGAR power standard also say something, but it's almost close. So they said it is 50 miles is classified as a short transmission line. So when the power is transmitted along a transmission line, what happens? It's a difference in condition at the sending and receiving ends due to the series impedance of the line. So power transfer depends upon the transmission line impedances. Impedance means what? Resistance, inductance, and capacitance. Okay, and this impedances, that series connection between a resistive and inductive element, it is shown in figure. If you see the figure, they show you R and X. X is what? Reactance. XL means inductive reactance. This is the, they show you in the short transmission line. This is, we can say, impedance. Impedance means this is R and L, R combination, R and X combination. So they said here the Vs is the sending end voltage and Vr is the receiving end voltage, sending end and receiving end voltages, and Is similarly sending end current and Ir receiving end current. So from this, what we conclude, since there is no shunt capacitance, that already we conclude, whatever the case, the short transmission line, there is no shunt capacitance in the transmission line. So we have to come for the conclusion, what is the relationship of the current and what is the relationship of the voltage. So the relationship of the current for sending and receiving end, okay, IR equal IS, because there is no shunt capacitance connected in the short transmission line length. Okay, next one, we want to make a comparison of sending end voltage and receiving end voltage. So always we think about receiving side. Why? Because this is the output. So we want to write from output VR equal sending end voltage input Vs minus this IR by R plus j omega L. So this is, see again, it is I by R, that is voltage drop. Okay, so this is I by Z. Okay, so it's a, for example, Ohm's law of AC circuit. What is the Ohm's law for AC circuit formula? V equal I multiply Z. So if you want the drop, if you reduce the drop, okay, and when you send the voltage, the remaining you get the VR. Okay. So next one is a medium line. The medium transmission line and the line length, they set 50 to 150 miles. Okay, that is the another unit of the length. Okay, and for the shunt capacitance, it is added because of medium. Okay, and the extra element needed due to increase in the line length, increases of the capacitance. So if you see the figure here, this is the setup. The input side they mention here Vs, sending end voltage, and output, this is the load side, receiving end voltage. Okay, so now we have, this is the transmission line impedance R plus jXL, and this is the shunt capacitor connected, because the standard they set, if medium, you have to connect the shunt capacitor in the two end. One is for receiving end, another one is for sending end. Okay, so what are the other parameters we have? This is the sending end current, this is the receiving end current. Okay, and the capacitance we can write in terms of admittance, the half of the value. Okay, that is standard, this y half. Okay, and then we can say voltage in the load side is the receiving end VR and sending end Vs. So what we understand from this slide, this slide, we can see in the medium transmission line, capacitance are connected in both end, but in short there is no capacitance. Okay, the next one, long transmission line. So until now we study short, then medium. Short is there is no capacitance connected, and medium we have to connect the capacitor half of the value in both the end, that is sending end and receiving end side. The next one, we have to understand what is long transmission line. So the long transmission line is more than 160 kilometer as per the IEEE standard. Okay, so we have to connect the capacitor in many capacitor, not only the end to end. So they mention here the statement, a transmission lines grow in length, long length, affect the capacitance becomes more predominant. So this is the sizable component of the total current which the load the voltage by 90 degree, and the voltage induced by this current lags the phase current by 90 degrees. So voltage and current, the phase angle difference is 90 degree lagging, and produce the charging current. This reduces the necessary size of the sending end voltage. So the long transmission line, we have to consider multiple capacitor bank in shunt connect. The effect is most noticeable when the lines are subjected to very light load. Okay, when you are using long, but when you are connecting the very light load in the receiving end, and this effect is more. And the long line model is similar to the medium line. The difference is that the long line is represented by distributed parameters, but in medium line, lumped parameters. Okay, so that is, we can see in the diagram here, they connect many capacitor bank in the distributed side, distributed manner here. This is the sending and this is the receiving, but between many shunt capacitor bank. This is the transmission line impedances Z. Okay, so distributed manner they connect the capacitor bank. So that is the difference of long and medium. So until now, what we studied: short, medium, and long. The next one, so very important parameter the power engineer should calculate: voltage regulation, percentage voltage regulation. So what is percentage voltage regulation? It is the ratio of the difference of no load receiving end voltage minus full load receiving end voltage over by the full load receiving end voltage into 100. This is a percentage of voltage regulation. And the next one, efficiency of the transmission line. This is also very important parameter. A power delivered in the receiving end and power sent from the sending end. This is very easy. How much power you send and you have to receive how much, that is the efficiency. For example, you send 10 kilowatt and you receive 9 kilowatt. Okay, so you have to calculate the efficiency of the transmission line. How much power loss is there? That is the concept, is what we want to reduce the power loss in the transmission line, and we want to get almost a good sufficient amount of power what we send from the sending end to the receiving end. So that is the very important point here we have to consider. And like other electrical system, the transmission network also will have some power losses. We cannot avoid 100% power loss, and we can avoid certain power loss, so we can improve the system efficiency of the power network. Okay, and hence the performance of the transmission line can be determined by using efficiency and the voltage regulation. So that is our today topic, is what performance of the transmission line is based on what voltage regulation and efficiency. So voltage regulation is related to the sending end voltage and receiving end voltage. And what is the other parameter? It is the efficiency. Efficiency is related to the power transfer, power flow from sending end to the receiving end. How much power we get in receiving end after we subtract the power losses. But most of the power engineers and the power scientists, they try to minimize the power losses, then only they can get the good efficient transmission system. In all the country they are working, and nowadays very latest technologies are there, and we can minimize mostly less than 10% of the power losses, and by using the different technology, different material of the conductor, and many parameters that we can study in detail in the further chapters. Next one, why power is transmitted at high voltage? So this question is very interesting one. Okay, so now I give you some time to think why we want to transmit the power at high voltage, because we have low voltage, we have medium voltage, and we have high voltage. So why the power industry people, they prefer to send the power in terms of in the high voltage, not in low or not in medium? Okay, think, and then we discuss in this slide what is the reason and why they select the high voltage for power transmission. You can refer in the textbook or whatever it is. Okay. Okay. So now they give the reason why they select. The primary reason that power is transmitted high voltage is to increase the efficiency of the system. So almost all the power transmission network are designed and transmission line, everybody they think about the efficiency of the system. This is of course accepted. Why? Because if the power loss means what we generate we cannot utilize, or it is going in the air. So there is no benefit for anyone. And the next one is what? As electricity is transmitted over a long distance. Okay, when you transmit electricity, for example, now we are in Saudi Arabia, we transmit from Mecca to Riyadh. It's long, more than 600, 700 kilometers difference. So long distance, what happened? There are inherent energy losses because it's coming flow through the conductor. The conductor have the resistance and reactance and all those things. So it is make energy losses along the way each kilometer, okay, or each length. Okay, we have to lose the energy for every country, even the developed or developing countries. Then what they said, high voltage transmission they minimize the amount of power lost in electricity flow from one location to the next. How? That is the question. Okay. So what? How it is working? Okay. How it is minimize the power energy losses the transmission line when we send through the high voltage line. So higher the voltage means what? Lower the current. So the lower the current means what? The lower the resistance losses. Simple Ohm's law. You can see when you take the resistance, you pass the current. When your current, for example, the resistance is 10 ohm. When you pass the 10 milliampere, okay, so 10 multiplied 10 milliampere, 10 power minus 3. Okay. Another way, you have to keep it my 10 ohm resistance, but I say send now only 10 microampere. So that loss is very small. That voltage drop across the resistance is very, very small. When you calculate the power I squared R, that is very, very small. So now what they said in the power engineers, when you choose the high voltage lines, the current is lower. So when you pass the lower current through the conductor, so the resistance losses in the conductors are very low. So that is the concept they are using high voltage for transmitting the power. So what happened once the energy loss is minimum, automatically the efficiency of the system is increasing. But it is applicable for all the cases? No. Only it is mostly people are using for long transmission line. Why? Because that is mentioned in terms of kilovolt higher voltage. Now the people they are using extra high voltage also, EHV. Okay. The next one, electrical engineers, the transmission line operators or designer and power engineers consider factors such as power being transmitted and the distance required for transmission when determining the optimal transmission voltage. So they select depends upon the transmission line length and they select the optimal transmission voltage for what? They want to reduce the power losses. Why they want to reduce the power losses? Because they want to increase the efficiency of the system. So this is the reason the power engineers or electrical engineers they choose the high voltage for power transmit from one place to the another place. It's okay? Good. The next one, economical benefit. So always we cannot think about the technical benefit because now all the utilization industry, power industry, they think about the economic, also very, very important. Okay, so for economic benefit, so what they are doing, this is also on economic benefit associated with the high voltage transmission line. The lower current that combines the high voltage transmission line reduce the resistance in the conductor as electricity flow along the cable. So the conductor resistance is reduced and energy losses are reduced, and this means that the lightweight wire can be used for long transmission line. So what they mean here, not only for energy losses, when you send the lower level current, you can select the lightweight cable, it is enough. If you send the very high current, you need the more heavy weight and heavy capacity cable conductors. So this is one of the another advantage. So once you go for lightweight wire conductor for power transmission line, automatically the price is very less. So this is the one of the economic benefit when you choose the high voltage line for power transfer. Okay, the next one, as a result, so what happened, the transmission towers do not need to engineer to support the weight of the heavier wires that would be associated with the high current. These considerations make high voltage transmission over long distances an economical solution. So what they conclude, the engineers, they select high voltage line for power transfer for long transmission line. So they have the economical benefit, okay, and how? Based on the, they send very low current through the conductor, so they don't want heavy conductor, and they need only light wire conductor, so that cost is very less compared to the heavy wire conductor. So this is another advantages when we choose the power transfer for the high voltage line. Thank you, my dear student and video YouTube watcher, and if any comments or any questions, I'm welcome, and you can put in the description, or my students, they can contact me through my email, official email, and my WhatsApp also. Okay, then we will see in next class with another topic. Thank you very much for your cooperation and watching my channel. Thank you.